Hello, welcome back. So this is the fifth video lecture for chapter 9 about abstract class and interface. So in this lecture, we will cover the second interface example in our textbook. It's Java Interface Example 2, okay? And we have one package, and it has a house.java file. And we are also going to discuss the livable arable area comparator .java file. For the other two, they are the knowledge exchange for knowledge exchange. Okay, and we also have the test driver Java interface example 2. Okay, first, let's take a look the house class. Okay, and it belongs to the resource package. And next, let's take a look at what are the class that we import. Okay, we import the data class from utility package. We also import simple data format. This is from text java.text package. And if you take a look here, we have that comparable interface. Okay, it's from Java language package. And for this house class, if you take, it's not abstract, it's concrete class. So as usual, okay? And it implements both the clonable interface and the comparable interface, okay? For the clonable, if you recall, it's marker interface. Okay, so there is no method within the interface. And comparable interface is a functional interface. So it has only one abstract method. We call it a single abstract method, so SAM. Okay. And the comparable interface is a generic one in our case because it's regarding our house class. So that's why within the angle brackets, you plug in this concrete class house. Okay. And then for this house, we have address, livable area, and the construction date. So the type is date. So this is reference type. Okay. And we also have a static class variable called format. The type is static, the symbol data format. So you can see in this house class, it implements two interface. So yeah, so you can see a class can implement multiple interface, but it can only inherit from a single class, okay? And then we have constructor as usual. We have the accessor, okay? But here, be careful for the constructor for the date. Is it the construction date because it's a reference type? To avoid the aliasing issue for secure coding, here we do the deep copy, okay, from the data class, okay. We are not going to directly just do the date assign because that will cause an aliasing problem, okay, have security issue. And the same thing for the get construction, we use the clone. So return the deep copy. This is also for security consideration. And then let's see, toString nothing new equals nothing new. And then let's see here. We have also defined this shared construction date reference. So you pass in another house, okay, and you want to see if both house construction date are reference equal. Okay, so we want to do this check. Okay, so shallow copy. And because of the vulnerable interface, is it here we also override the clone method. Okay, we provide our own implementation. So we create a new date and we just use the same address and livable area, but using this new date for this copy. Okay. Let's continue. And because of the implements comparable interface, that's why here we needed to implement this compare to method. And it's another house. You're going to compare your house itself with another. So compare this with this other. Okay. So you can call the equals to check. This is for structure. Okay. Because for the compare to it to return negative value 0 or positive value 3. So if both are structurally equal, you return 0. Okay. And also remember comparable interface, it's natural ordering. So natural ordering is what? It's some specific compare rule. Comparison rule, okay, specific one. So here what we do, we first compare address. First, regarding address comparison, okay, either 0, 1 something, that after that, second, so if both address the same, then you compare livable area. That's the second criteria, okay? And if both the address and livable are the same, then you use the date for comparison. Okay, so this is our specific comparison rule. So whenever you have a house, if you have an object, two house object that's uh, created with this house class, and when you want to do comparison, then you have to first compare their address, then compare livable area, and then construction date. It follow this specific rule, okay? Because this house class implements a comparable interface. Okay, then let's see. And if you recall, when we discussed Java, predefined Java interface, we also discussed the comparator interface. Okay. For the comparator interface, and if you recall, we previously said it's a independent class that's going to implement this interface. So what here is going to do, if you take a look, its method you need to implement is called compare. For the compare, it compare the two objects and the two objects type based on the generic type from this comparable interface. So here you're going to compare two house, okay? So be careful about the difference between this class. This class doesn't belong to a house. So it's a selves. Okay. And its purpose is to compare two house objects. Okay. Then in this case, okay, what we said, okay, for this specific comparison, we just want to use the livable area for comparison. So you get the first house, second house, the living area, and then you compare. Okay. So this is not the rule as a house comparable interface define. It's its own rule, okay? And then because of this, you can also have address comparator. You can also have a bedroom comparison. So you can have different type. Is it? So that's why we say comparator interface. It's total ordering. It gives you, so it allows different kind of comparison rule, is it? So allows multiple rules for comparison. So it's more flexible, is it? It's provide more flexibility for comparison. Okay, and also comparator interface, you can see it's also a functional interface. Okay, so this is about comparator interface. Okay, then next, let's take a look at the driver. Okay. So for this driver, what we first create is, hold on. Because the house class and the livable comparable class both are from the resource packages, we need to import that. And in this test driver, we are also going to use array list and arrays and collections, date, and Georgian calendar. Okay, so we need to import all of those. And first, let's see, we have a date object created. Okay, so we use this new Georgia calendar and its return get type. The return type is a date. Okay, then we use this date to create our first house. And then we have the deep copy clone the house. Then you can test if both are the same. So definitely this should be false because they are two different objects. Okay. How about the get class? Yeah, the get class should be true. Okay. And then the equals, so structure comparison, is it the structure equality check? That should also be true. Okay. Okay, then next, let's see. So now next we create an array of a house. The first one is the house we just created. Second one, we create a new house. Okay. And the third one, we create another new house. Okay. And so this array type is a house. Then we want to sort that. Okay, so array has a method called set from the arrays class. Okay, and let's take a look. The arrays class. Okay, release the arrays. Let's see, probably this one. Yeah, I believe it is this one. Okay. So this is the arrays class. Okay. And it does have a sort method. So sort the method and it take in an array, is it? But be careful, the type should follow nature ordering. Okay, so our house implements comparable interface. So that's why you can go ahead directly plug in the house array. Okay, it's because of natural order. If the house doesn't implement a comparable interface, if you want to that will not work. Okay. And next, let's take a look first here, okay, so that later on we can come back. Okay. And this is regarding the collections interface. Okay, in the collections interface, it also has a method called sort. Okay, and it has another method called the sort method. For the first sort method, it follows nature ordering. Okay, so this is a comparable interface. For the second sort method, it's going to sort a list. If you take a look, the second parameter type is that comparator interface. Okay, so if you want to do the total ordering, then you call this sort method. And here, this list is also an interface. Okay, and array list, and our array list, later on we will see array list basically implements this list interface. So that's why you can plug in array list. Let's see. Okay, yeah, here comes our array list. So if you take a look at array list, it says implemented interface include list. So that's why you can go ahead to use it. And also implement clonable. Okay, we already learned that. And okay, let's go back to our coding. Mm. Okay, then we just discussed, is it? That's why here you do this sort. And this sort is using natural ordering. So that means it comes from the comparable interface. It's a definition, okay? And then it will output. So it's first by address, then following by livable, etc., and then a bedroom or a or build a year something, okay? Now we can take a quick look to see the without sorting house. Sorting house. Yeah, sorting house. If you take a look here, address, both address the same. Is the living area also the same? Then to use the different construction date, is it? And following that, it will go with the address. Okay. Yeah, so it does do what the comparable interface defined. And then next, let's take a look. What's the next one? Here we do the sort, okay. And then next one is we build an array list of the house. Okay, this is array, and here we have an array list. The array list you can add, okay. And the collections also has a sort method. And array list to implement that list interface. So you can plug in this array list for sorting, etc. And for that sort, it's also natural, I remember, natural ordering. So the result should be the same as this sort. These two should be the same, okay? So we can take a look the result. So this is sorting array list. Sorting array list. Yeah, sorting array list, if we take a look, when the address is the same, they use the date, okay? And if address is different, then they use address for comparison, yeah. So exactly the same as the previous one, okay? And then next, let's see what it does, okay. Oh, so this is regarding in array list. So array list has methods. So this is kind of like a search method to check if the array list has a class. Yeah, it has. Is it? So that should be true. Okay. And then it says if it contains the clone, is it? Then we will see. Probably not. Okay, let's see. And then the array size. And then over here, the array list can also have array list also has a function to convert the items to array. Okay, and then you need to specify the type. Is it? So the type you want it to be house. Okay. After that, you can do uh, this is for deep copy comparison of both array. Okay, yeah, and we can see. So this is basically a structure. Okay, structure on both the array as well as the contents. And let's see. So first, we are going to take a look at the result for the contains. Yeah, let's see. So contains, you can see it's true. Yeah. So that's the object. And how about the clone? Then it's not. Yeah. So basically, inside the contain, what it check? It check the reference copy. Okay. So we can get the result from it does that. And then this for the structure comparison, is it? So it is true. Okay, so that's regarding array list. It's application, okay. And then next, let's see. So array list also has a function clear, so you can clear off them, okay? And then we add as list, okay? You can add them all. And now we create another two new house 4, house 5, and you also add that, okay? Now, if you take a look this time, we call that sort method, second sort method. Second sort method, if you take a look, it is what? It is comparator interface, the total ordering. So by the living area. Okay, so yeah, so this time if you want to sort in living area, then you say you need to call that livable comparator, that class is a creator an object of that class. That class implement that comparator interface. So then when it do the sorting, it will use the total sorting. And we can see that for each loop, the output, okay, if it does rearrange. And if you take a look, did you see? Yeah, it does all sort based on living area. Living area. Yeah, it's sort on living area because you take a look, the address now, if based on address, this should be after 2. Oh, this should be 15, or I should be after 100. Is it? But you see, it's a first. That's because this living area is the smallest. Yeah. So this time the sort is based on living area. Okay. So that's the second example about interface in this chapter. So basically, we complete the discussion of chapter 9, and we are going to move to next chapter in the next section. Yeah, so see you next time. Bye.